right. Hey, y'all, it's Mr. Kyler, Mathematics. Let's just jump right into it. So we have number 34 in a series on series. And a sequence is kind of like something that's leading into a series, so we're not quite at series yet, but the sum of a sequence is a series, so we'll get there eventually. Which, for each of the following sequences whose nth terms are indicated, state whether the sequence is bounded and whether it is eventually a monotone, increasing, or decreasing. Okay, so I'm going to probably stop talking about what it means to be bounded and monotone, increasing, decreasing, all that, just because this is like one of the last ones in this set of problems anyways. And on some of the previous ones, I talked a little bit more in depth about what all that stuff was. So let's go ahead and jump in. I'm going to call this a sub n. And we're going to have some n values and some a sub n values. If n is 1, we're going to start at 1. If they don't say where you're starting at 1. Cosine of 1, it's roughly the cosine of pi thirds, because pi is about 3, 3 over 3 is 1, roughly. So that's if I plug in 1, it's about cosine of 1, so cosine of pi thirds, which is the cosine of 60, which is about a half. Okay, what about 2? 2 squared is 4. 4, so we're talking about like, maybe the fourth multiple of pi thirds. Now we're getting even more outside of the realm of what the number would actually be. But just for simple math, we could say, okay, so 2. So, wait, did I say 4 pi thirds? No, it would be 2 pi thirds. Duh. 2 pi thirds, which actually would be negative, around a negative a half. Around a negative 1/2. And so on and so on. So it's going to continue doing that for a while. And let's see. So I'm going to put 3, 4, and 5. And then we're going to go to infinity and see what happens. So it's just the cosine of some sort of infinite value squared. And that's actually kind of undefined. Undefined. Because it is a wave and it's a never-ending wave. This is not a standard wave, though, because it's n squared. So let's take a look at what this graph would look like so we can get an idea of how it might be bounded and whether it's monotone, increasing, or decreasing, because, that is important to answer. So the cosine of 0 would be 0. No, it wouldn't. Just kidding. Cosine of 0 is 1. Okay, let's go like 4 spaces up. Okay, so cosine of 0 is 1. I was just checking to make sure you were paying attention, obviously. Cosine of 0 is 1. And the next good value would probably be pi halves. And then I'll go like every 4 spaces of pi halves here. So 1, 2, 3, 4. That's pi. 1, 2, 3, 4. 3 pi halves. 1, 2. Hold on. 1, 2, 3, 4. There we go. 2 pi. Okay. So that's 1 period of cosine. I think that'll be plenty. And we're going to go up to 4 spaces there. And do we need to go down? Because normally cosine goes down. But let's see. So if n is 0, cosine of 0 is 1. So that's 1. Okay, well, what about pi halves? Well, it would actually be pi halves squared. Like if I'm plugging in pi halves, it would be pi halves squared. So actually, those numbers are not necessarily going to be as nice as we once thought they were. Let's say, yeah, because pi half, that's not going to be, that's not going to be very nice. Let's see what that would be. What would be, let me make sure I'm in radian mode here. Got my phone calculator out. Okay, so sine of 30. Am I in degree mode or radian mode? Sine of 30 is a half. There we go. Okay, so I'm in degree mode. Let's change to radian mode. So I want the cosine, but I want the cosine of, let's try pi halves and see where it goes. The cosine of pi halves, but quantity squared. So actually, let me go back. Add an extra parentheses. Pi divided by 2, close parentheses, squared, close parentheses again. Negative 0.78. Okay. That's what I'm getting. Negative. So it is going down to the negatives. Oh, you know what? I was thinking of cosine squared of n. That's why I was thinking it might not go down below. 2, 3, 4. And I am just not on my A game today. So cosine squared of n, you would always be squaring whatever the cosine of that value is, and so that would always be a number between 0 and 1, since you're always squaring whatever the result is. And if the last thing you do is you square something, it's always going to be at least 0, but then it's still cosine, so it would still be going up to 1. But this is cosine of n squared, so that's different. Negative 0.78. So that's like around right here somewhere. Crazy. All right. What about like pi fourths cosine? Because I kind of want to see, because it's going to be changing the wave, but the waves, we're still going to get values because we're going to square. We're still going to get values that are between -1 and 1. But the wave just looks different. Let's see if maybe I can do this. Let me see if, pull this up over here. I'm going to pull up Desmos, and we're going to look at what the graph looks, because just so you can see what it looks like compared to a cosine wave, right? So I'm going to do that real quick, and if you want, you can kind of scrub past this if you've already done this step, but I do think this will be interesting to look at. So I'm gonna pull this up. So y equals cosine of x, and then let's do f of x. So to give the different names here. So f of x equals cosine x, and I'm gonna pull this over onto the screen that we're on, so you guys can see this in a second. Let me finish doing this. So g of x is equal to cosine of x squared, and it doesn't matter that I'm using x. Here we go. Okay. And that way we can see what this looks like. This is really interesting, actually. So, don't mind my millions of tabs over here. So check this out. Can you guys see that? Yeah. This is interesting. So if you look, it is between -1 and 1. Because you're going to be plugging in some sort of value, and then you square that value, and then when you square that value, it's still going to be, the cosine of some sort of angle. Then the cosine of some sort of angle is still going to be between -1 and 1. So it's still going to be bounded between -1 and 1, just like on the last problem, if you remember with sine. And you can see that, it's like, okay, well, there it is, Now, what it is doing, though, is as we go to infinity, it's getting closer and closer together. You see that? If I zoom out a little bit here, it starts getting more aggressive. And that's because it's squared. So if you square 2, you get 4. If you square 3, you get 9. But the larger and larger the number is that you square, the quicker it goes to infinity, right? So it's gonna start oscillating more and more and more, because you're going to be squaring larger and larger values, which then becomes even larger and larger, by a certain fold. So it will be getting more aggressive as it goes to infinity there. And I guess we'll go ahead and put this back over here. So I think that's plenty for right now. Sorry, it's taking forever to move. There we go. So we got to look at the graph. And come on. I'm trying to move it back. It's like this tiny little, like, gotta get it like just, why is it doing that? It's like this thing where you have to get it like just, normally there's like a window of options, but it's, okay, whatever, I'm just gonna leave it for right now. Okay, so it gets more and more aggressive, basically. So if I just kind of sketch what that kind of looked like, it would be something like, like this, and then like that, and then like that. Right, and then something like that. So, so it's going to look something like that as it goes to infinity. It's getting closer and closer together. Now, the answer. So Is it bounded? Yes, it is bounded. It is bounded from same thing as the previous one, from -1 to 0 and from 0 to 1. Because all of those important values um, are all those values are going to be, well, yeah, all those values are going to be irrational. All the values, so this is a little more complicated to explain, but all the values that are going to be irrational, um, like where it crosses the x-axis and where it goes from 1 to and from -1, they're all still going to be irrational numbers, and we're just not going to get those numbers because we're counting by ones, right? So it's going to be like the cosine of 1 and then 4 and then 9 and then, right, so on and so on. Those are all still rational, and not even just rational, but natural numbers. And in order to get an intercept, we need an irrational number because it has to be some sort of multiple of this, of like a square root of pi halves and pi and whatnot. So it's still bounded exactly the same way as a regular cosine graph or a sine graph. It's also not monotone, right? In fact, it's even less monotone than a regular cosine or sine wave because it's increasing in the amount that it's increasing and decreasing and like increasing in the amount that it's decreasing as well. So it's bounded, but it's not monotone. All right. So basically same answer as last time, but this graph's a little more complicated, so I figured it needed a little more explanation. If I didn't cover something that your teacher's looking for in part of the explanation, just let me know in the comments down below, and I'll make a follow-up video explaining it based on how your teacher's looking for it. So just give me some feedback, and I'd be happy to give a follow-up for this later on. But other than that, just go check out the 5 math mistakes everyone makes and how to avoid them. It's a little free PDF I have on my website, Myers Mathematics, link in the description below. And I'll catch you all in the next video. Blessings, y'all.